In this theorem, the statement of this theorem, there exists 1 and 1 correspondence between two left or right cosets of H and G. 1 correspondence. 1 correspondence between any two left or right cosets of H and G. First of all, we have to understand that what does it mean by 1 correspondence. So 1 correspondence means that we will define a function from one coset to another coset, and we will prove that this function is well defined, this function is 1 this function is onto. When this function is 1 onto and well defined, then we will say that there is a 1 correspondence between any two left or right cosets of H and G. So in order to define a function, we will must take two left or right cosets. So here I am taking two left cosets. Now for let consider a mapping. Consider a mapping, and this mapping is phi from AH to BH, such that phi of AH is equal to BH. So this function is defined by phi of AH is equal to BH. We will prove that this mapping is 1 mapping, onto mapping, and we will prove that it is well defined. So when this condition will be satisfied, then it means that there is 1 correspondence in these two left or right cosets AH and BH. There is 1 correspondence between AH and BH. So first of all, I will prove that it is well defined. Okay, this mapping is well defined. So in order to prove that this mapping is well defined, we will take just like phi of AH, okay, is equal to phi of AH is equal to just like in order to prove that this mapping is well defined. 1 minute, please wait. So yes, consider, or you can say consider AH1 is equal to AH2. This implies that H1 is equal to H2. Now we multiply on both sides by B. BH1 is equal to which is equal to BH2. Okay, so from here you can see BH1 is equal to BH2. The left hand side is BH1 and right hand side is BH2. When we compare this, it means that this implies this is phi of AH1 is equal to phi of AH2. Okay, so it is well defined. Okay, this relation shows that phi of H1 is equal to phi of H2, shows that this is well defined. Okay, because phi of H1, what we consider that AH1 is equal to AH2. When we consider H1 is equal to H2, then it means that H1 is equal to H2, and when we multiply BH1 is equal to BH2, so what we get, the final result is just like this function. When the final result on both sides is just like this function, then it means that this shows that phi of H1 is equal to phi of AH2. This means that phi is well defined. Now we will prove that phi is 1. In order to prove that phi is 1, we will take just like we have proved this one, phi is for well defined. Okay, now we'll take phi of H1. This is phi is well defined. This is phi is well defined. Okay, now we will prove that phi is the second phi is 1. Okay, for this, you know, the function that we have take 5, which is from the cosets AH to BH, and we define it just like as phi of AH is equal to BH. Okay, this is the function that we have defined in this way. So we will take phi of AH1 is equal to phi of AH2. So phi of AH1 is equal to BH1, okay, and phi of AH2 is equal to BH2. Okay, so this implies that H1 is equal to H2. So what does it mean by this? Means that this implies that phi is 1 1. Okay, after phi is 1 1, we will prove that phi is on 2. Okay, and here you can see that we can write AH1 after multiply. AH1 is equal to AH2. Okay, because these are the pre-image of phi. Okay, phi of AH1. So when we apply phi on AH, okay, this should be equal to its pre-image. Means from here phi of AH1, what is the pre-image? Pre-image is AH1, and here the pre-image is AH2. When we apply on phi of H1, we get AH1 pre-image. So pre-images are equal. Okay, images are equal. When pre-image are equal, then it means that phi is 1 1. And now we will prove that phi is on 2. In order to prove that phi is on 2, okay, phi is on 2. Phi is on 2. So phi is on 2. Of course, the function is AH1 to BH, and we define it just like as phi of AH is equal to BH. What does it mean by? This shows that for each BH belong to for each BH belong to BH, there exist AH belong to the cosets AH such that phi of AH is equal to BH. For each BH belong to, for each BH there is an AH which belong to AH. This means that phi is on 2. So when phi is on 2, this implies that phi is on 2. So this implies that if phi is 1 1 and on 2, then it means that phi is bijective. Phi is bijective. So any function which is 1 1 and on 2 function, that function is called bijective function. So phi is bijective. If phi is bijective, it is 1 1 on 2, well defined. Okay, so this means that number of element in AH is equal to, or you can say that order of AH is equal to order of BH. Means number of element in AH is equal to number of element in BH. Okay, so there is a 1 1 correspondence. This means that when phi is 1 1, when phi is on 2, and when phi is well defined, then this means that there is 1 1 correspondence between these two left or right cosets. Since we take only two left or right cosets, AH and BH, and these are arbitrary, so it is true for any left or right cosets. So there exists 1 1 correspondence between any left or right cosets of H and G. So this was the proof of this theorem. So I will meet you in the next lecture and we will do the Lagrange theorem.